So we have now represented our framework on the workspace here. So the next step is to conduct our data analysis. So to do that, we click on the calculate button and then we select the PLS algorithm. So by default, the weighting scheme is at the path, the maximum iterations is 300, and then the stop criterion is 7. Right, so we would have to make some changes to these settings. So the weighting scheme must be at factor, right, and then the maximum iterations must be at 5,000. The stop criterion can be left at 7. Okay, so you click on start calculation. Okay, so this is the output from the algorithm, and before we generate the final results for our study, we need to test for reliability and validity of the model. So we come to the construct reliability and validity. Right, so for the construct reliability, we have measures such as the Cronbach's alpha, the rho A, and then the composite reliability. Alright, so the rule of thumb is that the value should be 0.7 or above. Alright, so here under the Cronbach's alpha, with the OPT we are saying 0.610, right, which is less than 0.7, and that's why it's in red, right? But then when you come to the composite reliability, as we are seeing, everything is beyond 0.7, right? And in practice, the composite reliability is known to be a better construct reliability over the Cronbach's alpha, right? So we are okay with the construct reliability, right? Now let's look at this final column, and that is the average variance extracted. So this measures the validity. So this is a validity measure, okay? And the rule of thumb is that the value must be greater than 0.5, right? That's why for the FB, which is 0.191, OPT 0.235, TR 0.429, all these values are less than 0.5, and that's why they are in red. Okay, so in order to correct these defects, we need to go back to our model, and then we delete some of the questions from FB, OPT, and TR, right? Because those are the variables that are giving or that are showing values less than 0.5. So it means we need to correct this defect. So to do that, we come back to our model, okay, and then we are going to cancel out those questions that have lower values, preferably that are less than 0.5. Okay, so let's take some of the questions out. So here we are seeing 0.105, so we are going to take this one out. 0.144, we are going to, so if you want to select multiple questions, okay, you just hold the control button and then you select. So 0.360, select this one too. 0.410, we select this one. 0.326, we select this one. 0.44, and then 0.411, 0.260. So after selecting, you just right click and then we click on delete. Alright, So let's recalculate everything to see whether we are going to witness some changes in our output. So let's calculate again. So we come back to our construct reliability and validity, and still, as you can see, the value is still below 0.5, so it's now 0.329, but it's better than previously it was 0.191, so it means that it is improving. So we'll go back to our model and then delete more questions from the FB side. Okay, so let's delete some of the questions that are below 0.7. okay, preferably let's look at the least values. Okay, so we can delete FB1 0.502. it is a little over 0.5, so let's remove that one and let's delete this one to 0.5. so we hold the control button, we delete. So we can also delete this one to 0.511. okay, so we click on delete. Okay, so let's recalculate. Let's select our contrast reliability. It is still a little lower than 0.5, so let's go back to our model and delete more questions. So we can delete this one here, which is way below 0.5. okay, so let's delete only this one and see whether we are going to see some changes. So we'll recalculate. So let's check. Okay, so we are good to go. So FB has been rectified, so it's now 0.526, which is okay. So let's now turn our focus to OPT. So let's go and delete some of the questions from OPT. Okay, so this OPT, so we can delete. Let me reposition it so that we can see the questions well. Okay, so we can delete 0.140. We can also delete 0.099. Okay, we can also delete 0.415, 0.099, 0.425, 0.332. Yeah, I think let's delete these ones for now, and then we'll recalculate. Let's see whether we'll see an improvement. Oh no. So let's go back and delete more questions. So we can delete 0.585 and then 0.590. Okay, so let's try these ones. So let's recalculate. Okay, so we are sorted. So OPT is now 0.561, which is beyond 0.5. So the next one is TR. So let's go and delete some questions from the TR. So let me reposition it. Okay, so we can delete, let's delete 0.585, 0.503, and then 0.539. Okay, so ideally the value should be around 0.7 or above. You get it? So we recalculate. Okay, let's check. Okay, so TR has also been corrected, right? So we are done testing for construct reliability and validity. Alright, so let's look at another measure of validity, that is a discriminant validity. Okay, so we have various measures. We have the funnel-Lacka criterion and then the HTMT. Right, so with the funnel-Lacka criterion, the rule of thumb is that the first value should be greater than the values beneath. Okay, so here is 0.878. right, so the appropriate thing we are expecting is that all the values beneath this value should be less than 0.878, and as you can see, it is true for DET. So let's come to FB. FB2 is confirmed, so this is 0.725, and all the values are less than 0.725. Same with FFS 0.804, and as you can see, the values underneath are less than 0.804. FRT, same, we have 0.766, and the values underneath are less than 0.766. Same with FTS 0.758, and the values beneath are less. And then finally OPT 0.749, and the value under is less than. Okay, so we are certain about the discriminant validity using the funnel-Lacka criterion. So another measure of the discriminant validity is the HTMT. Okay, and here the rule of thumb is that the value should not exceed 0.9. So the maximum threshold is 0.9. Any value beyond 0.9 makes it invalid. So here under DET we are saying 0.921. So this is not really good for OPT. This is not too good for OPT. Okay, but at least apart from OPT, the rest are okay, right? So we can just fall on the funnel-Lacka criterion, okay, as our basis for determining our discriminant validity. So we are okay with the discriminant validity. So once we are certain about the reliability and validity of our model, the next thing is to generate our outputs. Okay, that is the results for the study. So we go back to our model, and then we go to the calculate option, and then we select the bootstrapping. So here we are supposed to change the bootstrapping technique from basic to complete, and then as usual we change the subsamples to 5,000, and we leave every other setting by the default, and then we click on start calculation. So this one takes quite some time. Okay, so let's wait. Okay, so we finally have our results, and let's look at them and try to interpret. So the first column here gives us the original sample, and these are the coefficients. The coefficients indicating the relationship between the dependent variable and the independent variable. Right, so here we are seeing 0.10, right, and it's positive, right? So that tells us that DET has a positive impact on FRT, right? Here too it's positive, so FFS has a positive impact on FRT, and FRT also has a positive effect on FB, FTS has a positive effect on FRT, OPT has a positive effect on FRT, and then TR has a positive effect on FRT. Right, so this is how you are going to interpret it. Right? If the coefficients were negative, then the interpretation will be that the first variable has a negative relationship with the second. Right. Now let's look at the p-values. So the p-values will tell us the level of significance. Okay. It tells us the level of impact that the independent variable has on the dependent variable. So since we are using the level of significance of 0.05, any value that is 0.05 or above, it tells us that there is an insignificant relationship between the dependent and the independent variable. Right? So here we are seeing 0.133. So this is insignificant. Right? So DET does not really have an impact on FRT because the p-value indicates that it is insignificant. The same with FFS and FRT. So the value here is 0.059. It is insignificant. Right? But then for FRT and FB, we are seeing 0.00. That tells us that FRT has a significant impact on FB. Same with FTS on FRT. So the value here is 0.00, and that tells us that FTS has a significant impact on FRT. But then OPT has an insignificant impact on FRT. And then TR has a significant impact on FRT, right, as you can see here. So that's how you interpret the results, right? Now, finally, let's test for the relevance of this model. Okay, so we go back to our model, and then we go to the calculate button, and then we click on the blindfolding. So here you have to change this setting, the omission distance. Because we used 7 throughout in our calculation, we are going to increase it by at least 1. Okay, so then we click on start calculation. Okay, so we have our output here. Right, so we are going to look at the cross-validated redundancy, and we are just going to look at the last column here. That's the Q squared. Okay, and the rule of thumb is that the value must be greater than 0. Right, so here we are seeing 0.067, which is greater than 0, and here we are seeing 0.147, which is also greater than 0. All right, so that tells us that our model is relevant. Okay, so these are the various analysis that we have to do for this particular data. Okay, so that brings us to the end of data analysis using the SmartPLS software. Thank you.